Hello everyone. This is the last video dedicated to the environmental behavior of persistent organic pollutants. On this video, I will be discussing how to perform calculations using partition coefficients. And I'm going to do it by using, as an example, an exam question from last year, I think. So this was an exam question that I set in last year's exam. You have a chemical, an organophosphate pesticide, diacenon, which is considered to be a relatively high toxicity for vertebrates. You have a 20 milliliter sample of water that has 0.2 grams of the pesticide, which is then extracted with 25 milliliters of octanol. And what will be, when the extraction takes place, what will be the mass of the pesticide in the octanol fraction? And I'm giving you one piece of data, which is the partition coefficient octanol water for diacenon is 6,393 at 25 degrees. So how will I go about tackling this problem? Well, I'm going to be calling D, will be my diacenon. So then I've got a certain amount of diacenon, 0.2 grams, and it's dissolving water. I then put it in contact, I put that water in contact with a certain amount of octanol. It says 25 milliliters. So at the beginning, the diacenon will be exclusively in the water. But once you have mixed the water and the octanol, the diacenon will be allowed to partition itself between the water and the octanol. So when you stop the experiment, when you stop mixing the two solvents, it will settle again. They are non-miscible. Both octanol and water do not mix, and you will have had a certain amount of the diacenon that will have stayed in the water, and another certain amount would have gone to the octanol. And that's what it's asking you, how much of that pesticide has gone to the octanol. So I've got my equation, and I've got the information of what is the partition coefficient of octanol water. So the next thing I do is I write down the definition of partition coefficient octanol water. So the definition of the partition coefficient between octanol and water is the concentration of the chemical I'm interested, in this case diacenon, in the octanol, divided by the concentration of the chemical I'm interested on, the diacenon, in the water. And I know the problem tells me that this is 6,393. So then I need to define what do I mean with concentration? What is concentration of diacenon in the octanol and the water? So I write it down. I write, okay, what is exactly the concentration of diacenon in the octanol? Well, it's going to be how much diacenon is in the octanol. And I don't know how much that's going to be, because that's what the question is asking me, divided by the volume of octanol I have. And that I know is 25 milliliters. And I don't know how much of the diacenon is in the octanol. That is what the question is asking me. So I give it a letter, an unknown, and you can choose any letter that you want to. In my case, I'm going to use the letter X, which is a very typical letter for a thing you don't know. So this is how I'm going to define X. X is going to be the mass of the chemical, diacenon, in the octanol. And now I need to define my other part of the equation of the partition coefficient water octanol, the concentration of the diacenon in the water. So I write again the concentration of the diacenon in the water. And now I say, okay, well, I know how much water I've got is 20 milliliters. And now, how much diacenon do I have in the water? And I'm going to ask you to stop 1 second the video and try to come up with an answer. Do you know how much diazinon do you have in the water once the experiment has finished, once the extraction has taken place? So stop the video, have a little think, and tell me. Okay, hopefully you stopped the video and have a little think and came up with an answer. And maybe the answer you came up with, Emilia, I know how much diazinon was in the water. 0.2 grams, you are telling me that. But no, that is not the answer. Originally, your 0.2 grams of diazinon were in the water. But once you mix the water and the octanol together and gave it a little shake and let it rest, some of the diazinon has stayed in the water and some has gone to the octanol. So you don't know. You honestly do not know how much of the diazinon has stayed in the water and how much has gone to the octanol. So I need to find another letter that defines, oh, I don't know this. I actually don't know how much diazinon has stayed in the water. And I'm going to use the letter Y, just because it's another typical letter that you use when you have an unknown. An X you have already used. So Y is going to be how much diazinon is in the water at the end of this reaction, when the extraction has taken place. So now I can go, I'm going to go to the next slide, and I write, okay, so I started with my definition of partition coefficient water octanol water, and I say, oh, it's the concentration of the chemical in the octanol divided by the concentration of the chemical in the water. And then I say, concentrations, I'm going to make this into mass of the chemical. So how much of the chemical, how many grams of the chemical are in the octanol divided by the volume of the octanol. And for the concentration of diazinon in the water, how much diazinon do I have in the water? I don't know. I know how much I had at the beginning, but not after the water and the octanol mix, divided by the volume of water. Okay, and I know this value. I'm going to go back because I actually don't remember. Oh yes, it tells me 6,393. 6,393. So I've got this. And now I have a problem. I have a problem because I have one equation, but there are two things I don't know in that equation. I don't know X and I don't know Y. So I cannot solve this equation because you can only solve an equation with one unknowns, and you need as many equations as unknowns you have. I've got two unknowns, X and Y. I don't know how much diazinon is in the water, and I don't know how much diazinon I have in the octanol. So as it stands, I cannot solve it. But there is something that relates X and Y. What do X and Y have in common? There is one thing that X and Y have that links them. There's something that relates X and Y. The mass of the diazinon I have in the water, the mass of diazinon I have in the octanol are related, and they're related by something that is in the text of the question. So I'm going to ask you to stop the video now and again have a little think. What do I know that relates X to Y? And it's in the text of this problem. So stop the video now. Hopefully you stopped the video and had a look. Did you come up with an answer? I'll tell you what the answer is. I don't know how much is X. I don't know how much diacenon is the octanol. And I don't know how much of diacenon has stayed in the water. But what I do know is how much diacenon I have in total. Because the problem tells me that. The problem tells me I've got a sample that has 0.2 grams. Which means that how much diacenon I have in the octanol and how much diacenon I stayed in the water have to add up to 0.2. Because that's it. That's how much diacenon I have in total. And some of it will be in the water and some of it will be in the octanol. But both quantities combined will give you how much I started with, 0.2 grams. So now, if I use what I came up with before in the previous slide, the fact that I don't know how much diacenon is in the octanol and how much has stayed in the water. But what I do know is that both combined will give me how much diacenon I started with. Then I can put X in function of Y or Y as a function of X. And because because the question is asking me how much diacenon is in the octanol fraction, and that's X, that's what I'm looking for. I'm going to try to get rid of the Y in this equation and leave everything as X. So I write, okay, the amount of diacenon in the water is how much I started with minus how much has gone to the octanol. So now I use my newly found equation and I substitute this. So instead of writing Y, I write 0.2 minus X. So if I write the equation again, I end up with X divided by 25. That hasn't changed. The 20 hasn't changed. Instead of writing Y, I now write 0.2 minus X, and this is 6,393. And that is an equation we can solve. It doesn't look very pretty. It definitely is going to have a lot of processing and moving around and moving around numbers, but it is one equation that has one unknown, X. And if you do the calculations, you will come up that, give or take, depending on how you use your calculator and reject decimal places, etc., roughly 0.19 grams. So roughly of those 0.2 grams of diacenon, around 0.19 grams have gone to the octanol, and only a very small proportion, 0.01 gram, has stayed in the water. So I hope this was useful, and I hope it helped you get your head around the problems. You have a few to practice with in the module Blackboard, so please have a go at them. And if you have any questions, we will solve them. We will go through these problems in a future workshops. But if you have any questions or doubts, please either post in the discussion board for the module or email me. And thank you very much for watching.